Hello, I'm Dr. Mary Johnson. I am the pioneer of the approach SILMA, Success in Learning Math Approach. SILMA has been used with many students throughout the country and outside of the United States. The main components of SILMA are that to learn any math, any subject in math, you need to have 3 questions answered, and many of you have heard me talk to you about these questions as we go along. What are the numbers in this topic, whatever topic we're going to talk about, whether they're rational numbers, whole numbers, you know, we've gone through that. And then you have to know what are the operations, and that's very important because we don't just want to know addition, subtraction, multiplication, division, but we want to make sure we understand what those operations are and how to perform them. And then the last thing is the last component of these 3 questions is what are the math laws? As you know, this is the way I teach. You must have a law for every process that you do in math. And after that, then you can really learn whatever topic it is that you're trying to learn. And in the system, we start with a topic, we have objectives, we do a diagnostic test, you know about the diagnostic test. Then we have lessons, math laws are always there, examples, practice problems, and the last thing some of you have gone through is the certification of mastery test. And that takes one objective that you missed, had instruction on, and then you get a little quiz on it, 4 or 5 questions, and you show that you really know it. And that's the essence of what we do. And it doesn't matter what topic, what subject, we use those same principles for SILMA. And it has been very successful. Okay? We're going to look at adding fractions in a little slightly different way than many of you have learned and have forgotten and learned and forgotten. But this way, I believe you will always remember. We're going to start out with, of course, the math law for adding fractions. And what do you think that law is? It's you can only add fractions that have the same number where? In the denominator. Good job. You can only add fractions that have the same denominator. 4/5 plus 1/5. You can add 4/5 plus 1/5 because they have the same denominator. But when we add this, we have 4/5 plus 1/5, and everybody knows it is 5/5. And 5/5 is equal to what? 1. 5/5 is equal to 1. And when at the law, I'll give you another math law. First law I just gave you was you can only add fractions that have the same denominator, right? Second law, we can write fractions for every division of an object. The only qualification is you must have the object divided into equal parts. That's a key word that many of you miss that. You have to have equal parts when you add fractions. So when we have 5/5, that means we have the entire object. 4/5 plus 1/5 equals 5/5. And whenever we have the same number in the numerator as we have in the denominator, we know that we have divided the object into 6 equal parts, and we have the whole part, so it's equal to what? 1. That leads us to a very important law. 6/6 equals 1, 5/5 equals 1. 8/8 equals 1. The law is if the numerator and denominator are both equal in a fraction, then that fraction equals what? 1. Now, the next law you need to know is when you multiply a number by 1, 1 times 10, you get the same number. When you multiply a number by 1, you get the same number, 10. Okay. So this enables us to change any fractions that we have to any denominators that we would like to have by multiplying by a form of what? A form of 1. Yes, a form of 1. We can change the denominators. So whenever you're given fractions that have unlike denominators, you can change it. by multiplying by a form of 1, and you're not changing the value of the number. No more than you're changing the value of the money when you go to the store, go to the vending machine. You want to put in what? $1, but this machine needs a quarters, and so you may have to go and get quarters, okay? But the 4 quarters is going to equal to what? The same $1. Okay, so let's look at this. If we want to add 2/3 plus 1/3. We know the answer. Everybody got it?
1.
3/3, 1. All right. Now let's look at this one. 2/5 plus 1/7. The denominators are not the same.
Oh my God.
You cannot add the numbers this way. What do you have to do? You have to change each one of these to get equal same denominators. A fast way to do this.
Multiply the denominator.
No.
Common factor.
But how do you do that? No. Let me tell you. Wait. We're going to take the denominator of one of the fractions and form 1. And what would that be? What's 7 over 7? 1. We're going to form 1. 7 over 7 equals 1. We're going to form 1. And we're going to multiply 2/5 times 7 over 7. Did we change 2/5? No. Did we change 2/5?
No.
The form, but not the what? Value. Right. We're going to take 5 and write the denominator over here and write the form of 1, 5/5. And we're going to multiply what?
1/7.
1/7 times what?
5 over 5.
5/5. Okay. Now we have. Are we sure to have like denominators?
Yes.
Yes, because we made sure. We made sure we had. Because anytime you're going to use the same denominators, change to a form of 1, you're going to have the same denominators. You don't care about the numerator, just denominator. All right. So now we have.
14.
You know how to multiply? You multiply a fraction, numerator times the numerator, 14.
Over 30.
Denominator times denominator,
35.
35. 1 times 5,
5. 35.
7 times 5.
35.
Why is 5 times 7 equals 7 times 5? Why?
Because you just switched the numbers.
The commutative law. Some of you already know that. The commutative law. Commutative law. We're not going to worry about the name right now, but I want you to know it. And so we get 5 over 35, and now we can add the fractions. 14 plus 5. I bet you anything. I bet you Mackenzie can tell you what that is. You got it. 14 plus 5, Mackenzie.
I know that.
Mackenzie.
You said 15 or 14?
Mackenzie.
19.
19. Mackenzie just came out of kindergarten a couple of months ago. 19 what, Mackenzie? 35ths. 19 35ths. Now, sometimes you will get a fraction that you can simplify. But you already know how to simplify. You throw in the ones and you see how many ones you have. 1 times 1 times 1 times 1. And you get the final answer. Okay. Now, I want to make sure you have this. So, the next thing is what? Practice! Woo! The next thing is practice. You have your lesson. How long is the lesson?
3 minutes.
3 minutes. Lesson 3 minutes. Got the math laws? You know the math laws?
Yes.
And now we do examples. I've done examples, and now you do practice. Okay? 5 questions. 5! Your certification, you always give you 5 questions because that sort of mix it up a little bit. All right, let's do these really fast. I'm coming around to see how you do it. Those who get 100%, I have an award for you. Okay. This is not. Now this is unusual, isn't it? You don't get awards.
What's the prize?
I better get that.
A knowledge, is it?
Class. And just
More
let her
than
do
that.
it.
Let's do it. All right, the prize is do it. All right, here I come. Ready to check. Ready to check. Ready to check. All right, come on, Mackenzie. Let's go. 9, these are 5 questions. Let's go.
1/3 plus 1/5.
All right, I'm ready to check. Okay, that's fine. Okay, it looks like you're going along fine here. And you know what I'm looking at? What am I looking at?
Process.
Process. You got it. I'm looking at the process. Because what do I get for the answer? 1 point. What do I get for the process? 99%. Because the process enables you to do more problems. Whereas you get one answer, you have one answer. Got that? That's a great thing about working here in the Tennis Foundation. I get to see the students come in grade K, go all the way through, graduate, come back and help us. Many of the students you see around here who were in the tennis program before, I taught them in grade K. Now, since we've been here, notice what's happened. Some of you have no issues, no problems, because now you are operating, what, 2 and 3 grades above grade level? Aren't you?
Yes.
How many grades above grade level? 2, I think it's 2, 3. 2 or 3 grades above grade level. In your last diagnostic test and in your last standardized test, you're operating way above. All of you have shown great progress. We have several students who are 4 and 5 grades above grade level using SILMA. So we've had great success here, and I've also gone around the country teaching in other states.